All right. Let's see if mic is working. All good? All right, so we still have a couple last folks coming in here. Sorry for the last minute change. I think Stephen was getting thirsty, so I'll try to keep this short. So yeah, you've made it almost to the end. You still have to suffer through me, and then there will be a lot of fun and games outside. So we have a community corner. So if you have built something really cool with Vaadin and you want to show it off, we have a little mini stage here where you can plug in and just show for 2 minutes, 3 minutes, however long you want to show something cool you built to your friends here. We'd love to see that. There will be refreshments and drinks and everything that you might want. Good. All right. So let's get started. So today I want to talk about enterprise AI patterns. So for the past year or so, since last Vaadin Create, I've spoken at probably 15, 20, 30, I don't know, very many places. I've been to very many places. I've lived on an airplane, and I've spoken about AI. And during that, I've spoken with so many people who are very early on, some are very far on. And I've started to kind of understand what are some of the things that AI may be good for, maybe not so good for, in specifically the types of apps we're building. So I think most of us here are building enterprise applications. They're not the cool apps on the App Store that all the kids are downloading. They're the kind of apps that are running back of the office, making all the money, making the world run. So very important applications, but also from speaking with you all, I know there are a lot of kind of inefficient workflows in these applications. There's a lot of mundane work, people sitting in cubicles, clicking around for days on end. And I think that if we use AI in a good way, there are a lot of things that we can improve in these applications, make the workflow smoother, save people time, effort, help them build, kind of spend their time doing more meaningful things. Now, the right way of using AI is not necessarily using AI for everything. I kind of see at this point people are just throwing stuff at the wall and see what sticks. So I'm not saying necessarily use AI for every single thing that you could possibly think about. There is definitely nothing wrong with programmatic code. It's usually the best way of going about it. If you can do it, great. But at the same time, there are a lot of things that we couldn't even think about doing 2 years ago that are surprisingly simple to do today. So let's explore those things. And really what I want you to get out of this is just some ideas on specific little things that you could start exploring in your own applications to see would that make sense? Could we make our end users' lives easier if we were to do this? I want to show that AI is not just this ubiquitous chat interface that you see everywhere. That is very powerful, that's very useful, but also that's one of the kind of most difficult beasts to master because you just have one open text field where the user can write literally whatever they feel like, and you need to somehow produce something meaningful out of that. So there are a lot of more specific tasks that we can hand off to AI where we can have full control over the prompt and kind of just take this one specific task and make the AI do that for us. And that can be super powerful. For us as Java developers, there are very good news. Since last year, there have started to be AI libraries for us to use. So last year when I spoke here, I was talking about LangChain for J, which at that moment was pretty much the only game in town that had really anything to offer us as Java developers if we wanted to build an app on an abstraction layer that was more than REST. I'm very happy to say that the Spring team has worked very hard in this kind of year since then and produced Spring AI that we already looked at today with Josh earlier, and it's a super capable library. And what's really nice is that it's built by the Spring team that has just decades of experience building kind of easy to understand, maintainable libraries. So when you start working with it, it will feel very kind of familiar to you. It works very similar to other Spring libraries. It makes sense. And that makes it very approachable to us as Java developers. We don't need to understand what's going on in the neural networks and LLMs and all of that stuff. It's essentially just an API that we can call, similar to accessing a database or any other system. So it's super straightforward to build applications using this. But before we can get there, we need to kind of take one step back and just consider how do we interact with an LLM. So LLMs are these kind of non-deterministic systems that provide useful or non-useful answers depending on how we ask them. And the way we ask them, the way we prompt them, really makes a huge difference in how good the answer is that we get back. So it's very kind of worth for us to spend some time learning how do we most efficiently communicate with this. And it's not entirely different from communicating with people. Like I've noticed I've probably gotten better at communicating like my needs to other human beings better by spending so much time talking to LLMs, because you need to be very specific. So prompt engineering is sort of like programming, except there are no rules and nothing is deterministic. So it's good times all around. It's a lot of trial and error and fun times. So the first thing you want to make sure is be as specific as you can. So if you just give it a vague question, you will get a vague answer that probably includes a lot of made-up stuff. So it's like you get an intern for the summer, you ask them to build an order processing system, you end up with a PHP system. Like, you should have probably told them to use Spring Boot and Java, and that would have given you a better result. Be specific about how you want things to be structured. So in text, you might want to say, like, use bullet points, give me a step-by-step instruction list. When we're building something in Java, we might want to say, give me back a list of objects of this type, and that's going to be very much more useful for us when we're consuming that data coming out. Be sure that you give enough context to a question. So if we asked an LLM, how do we build a button? Like, if it doesn't know if we're trying to do that in HTML or Vaadin or some other framework, it's going to struggle to give you a very useful answer. So as much as possible, try to give the kind of context and constraints to what you're trying to do, and it'll give you a much more useful answer. Sometimes it's super useful to give a couple of examples, few-shot prompting, they call this. So if it's something that has a pattern to it, if you can give a couple of examples of that, it's super good at just following that pattern and give you kind of examples that follow that. If you're trying to do something more complex, oftentimes it's more efficient if you can give it a couple of steps, like break it down into steps and try to follow these, and it'll do a much better job at that. And that's similar to if you ask it to kind of solve problems. So if you sort of know the steps needed, you can guide it on the right path. And one thing that's also super helpful is giving it a role, so using a role prompting. So this is essentially guiding the LLM how it should behave. So it sounds a little weird to just like if I walked up to you and said like, hey, you're an expert at Vaadin and tell me this, but in the LLM terms, we're kind of setting it, because it's kind of, the way they work is that they kind of generate tokens based on some probability. And if we start by saying like you're an expert at Vaadin, that kind of makes the probability of the next things that they're Vaadin related very much higher. So by telling it how it should behave and who it is, you improve the quality of the responses quite dramatically. And perhaps the most important thing is that this is not just try it once and either it works or it doesn't. Keep iterating, try adding more prompts, iterate, go back to the beginning. Like, this is great because like the LLM has infinite patience. You can restart the same kind of dialogue multiple times over and over again until you figure out like what's the best way of doing this. And once you have that, then you can take that into your program and make that happen at the click of a button, and it's going to work quite reliably at that point. So just look at this as an engineering task where you kind of iteratively learn and build stuff. So let's take a look at some code here. I've built a little application where we can explore some of these patterns. And this is something I'm going to share the GitHub link to, so you don't need to try to copy all the code or take pictures with your phone unless you want. That's perfectly fine. But here we have some different patterns that I want to go through today and just see how we can use these techniques. So if we just start with the basics, we have a view here, a Vaadin Flow view that uses a chat client. So exactly what we did with Josh here a few hours ago, we instantiated a new chat view. And here in this case, I've used a message input component and we're outputting this. So whenever we call, we get the value from that event. In my case, I'm using stream, so as the LLM generates things on the back end, we're going to start showing that to the user as it happens, and then I'm just appending that to a markdown component. So if I say something like, hey there, it should show that. So if we now were to, for instance, do that thing that we just talked about, so how do I create a button? So if we ask something like, how do I create a button, it goes very quickly here, but it essentially says, like, I don't know what you're trying to do, but HTML seems pretty likely, so here's how you do it in HTML. But that's where kind of this comes in. So if we now say that we want to provide a system prompt, so this is us telling the LLM how it should behave. We could say, like, you are a senior Java developer, and you love to help others learn. And let's actually change this into a Vaadin developer, and maybe like provide step-by-step guidance. All right, that sounds very good. So now if we ask, how do I create a button? This should hopefully be grounded in the fact that we want to know about how do we build a Vaadin button, and now it's giving us step-by-step instructions and code examples and all of this stuff. So by being more explicit about what we want it to do, what is the context that it should behave in, all of a sudden it's so much more helpful to us. Again, but this is still just that like chat interface that we've all seen, but let's take a look at some more kind of enterprisey things that we might do. So I've heard that people in enterprises like documents. They gather many, many documents, and at some point they get overwhelmed by all these documents. So let's see if an AI that's actually good at just handling massive amounts of text documents, if it could do something. So in my downloads folder, I asked another AI to generate a simulated transcript of a sprint planning meeting. And here I've prepared kind of two ready-made prompts, one for summarizing that meeting. So if I didn't attend that, we can kind of pretend that we got this transcript from Zoom or whatever else tool we're using that summarizes these. So we can just upload this file and tell our AI here to please summarize this. So I think it's like 6 pages long. And here we get a pretty digestible thing. So conceivably, we could hook this up to a Slack bot that just shares it on the team channel after that meeting, saying like, hey, here are the things that happened in this week's meeting. Maybe that's still too long. Let's say, like, let's just go through this entire very long call that we had and just identify all the action points that were decided there. So in this case, I have a different mode, and I'll just give that same document there, and hopefully this should now just say which person should do what and by when. So yeah, Jennifer should do that by that day. So here, if we take a look at what we have, I'll open up the document analysis. Essentially, I just have two different prompts here. So again, nothing specific. So one asks the AI to summarize, and we're being very specific about what format, use bullet points and numbered lists to make it very easy to digest and skim through, and avoid including minor details. So we get a very thing. Whereas if we ask it to figure out action points, we're asking it to like figure out who is the responsible person who should do this and by when should it be done. And by that, we can kind of extract a lot of meaning out of this text. So we could kind of assume this as a part of a larger step where perhaps after a meeting, the notes get uploaded somewhere, we use an AI to transcribe them, they go through here, they go to Slack, they go here and there. So again, here we've kind of, even though it seems very similar to what we were doing earlier, the difference here is that we're not letting the user just provide a random prompt to us. We have full control over what the actual prompt is. We're just changing the actual input to that prompt. So because of that, we can spend a lot of time figuring out what this prompt should look like, how it should behave, what it should give us back. And we can do a really good job at that to make it as useful as possible. So that's something that I see kind of just as a general pattern as what we're looking here is that don't think of AI just as like this one chat-based thing, but think about like, could a button trigger something that's AI-driven? So let's take a look at a different thing. Here, we're in a pizzeria, Bob's Pizza. We have a bunch of customer reviews that we got in, and because we're so popular, we get so many of them that we don't have time to just read through all of them. Let's use AI to analyze the sentiment here. So here I have one prompt, if sentiment analysis. Let's see here. Where I just ask the AI to analyze the sentiment of the following review. Then I pass in the review as a parameter. So here we're using Spring AI's templating just to provide some structure to that. And then I ask it to return a sentiment which is positive, neutral, or negative, which I can then turn into enum in Java and show it here. All right, so that's all good. Now I can, I could conceivably flag any negative reviews and send those as an email to the correct store, and the manager will immediately be able to see them. Now, if we're working in customer service, maybe it'd be nice if we had some way of automating at least a template answer here. So what I did was I created a little template that just kind of looks at the review, the name of the person who sent it, and just drafts a starting point for us. So here, again, we have a system prompt saying that it should act as a customer support representative for Bob's Pizza and be friendly and respectful. And it should draft a response to this review by this person. And that gives us a starting point. Obviously, I spent very little time on this particular prompt, so it probably is not following, it doesn't sound the way that you would sound if you were actually doing this. But we could spend a couple of minutes on this, iterate it, give it some examples of how we want it to sound, and we would end up with something that's probably pretty good. So again, we don't have a big text field where people can just type in whatever. We have buttons that trigger very specific actions that we can predefine and make work. Nice. Then something that we definitely couldn't do last year this time is take advantage of the multimodality of AI. So in this case, I travel a lot, and that means a lot of expense reports. And as part of that, I need to kind of take pictures of all kinds of receipts and fill in things, and it's all very exciting and fun. But obviously, it's something that an AI could do as well. So what if I could just upload a picture and ask the AI to process that and present it to me in a Vaadin UI? So let's see if the conference Wi-Fi helps. All right, so I have a picture from Whole Foods, and it's got all kinds of things here. And there are a couple of things I want to show with this. One is, obviously, we're able to upload a picture and ask for something back. But specifically, what's pretty interesting here, if we look at receipt scan here, is that I've defined two records here. So I have a receipt that contains a merchant, the total, and a list of line items where each line item has a name and a quantity and a price. So I can pass the AI a picture and ask it to read the receipt and return the value in the provided. And then I just tell Spring AI to make sure that I get this back as a receipt that has a merchant, a total, and a list of line items. So that there's a lot of magic happening, but if we just look at the few lines of code we needed to do to make something like this happen, it's quite mind-boggling. If I told you you had to build this, I don't know, 2 years ago, it would probably have taken more than 5 lines of code. It would probably have been a whole project. There are businesses who are doing this literally. So it's pretty mind-boggling that we can do these kinds of things. So again, I'm not trying to say that this particular thing is the most cool thing, but just I want to kind of jog your minds to get kind of thinking about different ideas that are possible to do with AI today that weren't possible a year ago, 2 years ago. So take advantage of the fact that you can pass in audio, you can pass in images. Soon you will be able to pass in video too. And what could you do with this and a very well-crafted prompt? I think you can do quite a lot. All right. let's see. All right. So that's about prompting. So prompting does not just mean what you type into that text field, but it can be like these predefined actions, if you will, that you trigger from buttons or drop downs or as follow-up to something happening. Now, I want to really kind of dig deeper into that context part of prompt engineering, because that's really what's going to kind of make an AI system really useful or not super useful. The problem that we have in general when we're building AI-driven systems is that the LLMs themselves are generic. They've been trained on a lot of stuff, but what we're building in our businesses is very specific to the context that we're in. And if it doesn't know about that context, it's very limited in how useful of an answer it is able to give us. So the better we can get at providing kind of the right context for answering a question, essentially giving the LLM an open textbook exam where we ask it a question, we pass it a textbook open on the right page, and we tell it to read this first and then answer the question. It gets super good at answering questions. To get there, I want to just have a quick review of some stuff that we talked about last year, because everyone wasn't here last year and you might have forgotten stuff since last year. So when we're talking to LLMs, we are using something called a context window as our working memory that contains everything that's relevant for our discussion, our interaction with that LLM. So the LLM is completely stateless. So if we ask a question now and we ask a question in a minute, it does not know anything about the other question unless we explicitly tell it as a part of this context window. So into the context window, we need to fit a bunch of things. So first of all, we need a system prompt. That was what we were doing earlier when we said it should act as a Vaadin expert, for instance. We also need to fit our entire history of messages back and forth between us and the LLM. We need to have whatever our current question or prompt is. And in this case, we usually want to inject some relevant information into that helps the LLM understand how it should answer that. Especially if you're working with smaller models, it might be relevant to also make sure that you have enough room for the answer. So if you have a very small context window, you need to make sure that if you put in like 1,000 pages of background information, you left like this much room for the answer to get generated. Realistically, that's not the problem we're facing today. The problem we're facing today is that we're still getting charged by the amount of tokens we're using, so we have a built-in incentive not to like just put the entire library of documentation that we have into that context window. So that kind of gets us to how do we teach the LLM new things? How do we make it aware of our context? So LLMs in general know two things. They know whatever they've been trained on, which in case of the big models like GPT-4 or Llama 3 or Gemini or whatever, they've been trained on the entire internet. So very wide, given just until a certain point in time. The other thing that they know is whatever we pass in through that context window. So if we wanted to teach them new things, we have a few options. We could train our own model. This is great if we have a couple $100 million laying around in a few months to do it. Probably not what any one of us here in this room is going to do. We could fine-tune a model. So we'd start with an existing model, and then we start giving it some examples that are relevant to our business, our use case. So that's a fairly approachable, not super expensive, but still quite time-consuming way of doing it. The absolutely easiest and cheapest way for us to do this is to do this like open textbook exam. So we just make sure that when we ask a question, we provide any kind of helpful documentation as part of that question so that it can use that documentation as part of answering, and that way it becomes super useful. So that gets us to like, we have 1,000 documents. How do we kind of make sure that we only include the right ones so we don't spend any more money that we need to and still are able to provide the right stuff? So this is what we were doing with Josh and putting those dogs into the vector store and stuff, but this is in a few more steps. So the way we process documents into a vector store and how we make them available to the LLM is something along these lines. So we start with a document. We try to chunk it up into meaningful parts in some way. In this case, this is there's some semantic kind of structure to the document that allowed me to split it into some sections, but It's an engineering problem where you need to figure out how you want to split it up. Then comes the magic part. So we take each one of those strings, like parts of the document, we pass it through an embedding model. So this is an API we can call, and then we get a vector value back. And that vector value represents the semantic meaning of this piece of text that we handed it. And this is something that took me a while to wrap my head around, how do we get a vector value that represents text? Especially given that the text could be in German or English or Finnish or Swedish or whatever, and the vector value should be still the same. So it's not capturing the language of it, but the actual underlying meaning of the text. So one way to explain this that's worked well for me is to use an analogy with a color picker. So if you used a color picker, you can select a color value and you get a vector value of red, green, and blue. It's a 3-value vector, so it's a very small vector, but it's a vector nonetheless. If you select 2 values that are very close to each other in color, you're going to have vector values that are very close in their values. If you pick red and blue, their vector values are going to be very different from each other. So essentially what we're doing when we're creating embeddings out of text is that we're kind of picking these values out of a vector space that's not 3 values, but 1,500 values, 3,000 values. So essentially every number in this vector represents a similarity along some undefined axis. That's not super important. What's important to us is that the same rules of vector math apply. So vectors that have similar values are going to be very similar in their meaning. And that's why it's important for us to split this document in a meaningful way. Because if we had just passed this entire document into the vector embedding API, it would be like asking our color picker, what's the color of this entire image? You could calculate some sort of mean value of all the colors in the image, but it wouldn't be very specific as a question to ask. Whereas if we can ask, what's the color of my t-shirt, that's a much more meaningful question. So likewise here, if we can split the document into meaningful sections, we're going to get much more meaningful answers. So we take these, we plop them into a vector store. It's just a database that's good at doing vector math. And then if a user comes along and asks a question, we take that string, their question, we run it through the same API to get a vector value for that. And then we ask our vector database, hey, give me documents that are most similar to this vector. And provided it's good at doing math, which it should be able to figure out which documents in that database are most similar in meaning to the question that we had. So in this case, this is from another talk that I do, but essentially the document that we're looking at contains a terms of service document where one of the section is about cancellations. So if we ask about cancellations here, we can assume that the vector here in some way, shape, or form represents the meaning of cancellation, if you will. So then we ask the vector database, what in your database is most related to cancellation? And out of the 3 documents we have there, the cancellation policy should match that. So in that way, even if we had thousands and thousands of documents, we should be pretty good at picking out the kind of right things from there to include in our prompt. And that way we can both get a very useful answer, but also not use that many tokens as we had if we had just included entire, say, Vaadin documentation into every back and forth between the LLM and us. All right, so that's something that we looked at last year and something that's fairly straightforward to do with Spring AI out of the box. I mean, Josh and I did that in not many minutes. But there are some issues with this very baseline RAG that become apparent very early on when you start working with it. One is that if we have this longer discussion with it, say I asked what's Vaadin, answer something, then I ask a question what are its main features? Now if we try to just look at the sentence, what are its main features, it lacks meaning because it doesn't know what is it. So it's very important in these cases to rewrite the query so that it becomes a standalone question again. So we could rewrite it into what are Vaadin's main features. And again, then that would be much more meaningful for us to go into the vector database and ask that question. So that's something that's quite important as you start building kind of long-running discussions. The other thing is that a vector database is very likely not the only source of information that you have available to you. You probably might have already some sort of keyword-based search engine available. You might have the internet available. And one thing that you can do is you can essentially search multiple sources and then take the documents for each one of these and re-rank them. So like, let's say we search for the top 3 from each, and then we take those 9 and we select the best 4 out of those and include them in the final prompt. So that would allow us to get a wider kind of base material for what we're doing. In Spring AI, this is something that's quite straightforward to do, thanks to their advisor API that they've, I think they initially released it around June or so, and they've been kind of improving. If you look at this and you think that it looks kind of like HTTP filters or interceptors or any other concepts that you've seen in programming over the years, yes, it is. So they're definitely not trying to reinvent any wheels here, but like work with proven concepts. So essentially around that request response, we can add any number of advisors that will intercept first the request going out. It can rewrite that request, and then on the way back, it can again look at what the response was, and it can do something for that. And you can add as many of these as you want. So if we go back to our application here, let's go here, and I'm gonna just go here to our basic call, and I'm gonna change this just to kind of highlight a point. So go here, let that reload, and then we'll ask a question. So I have a document here that I'm going to use about the Spring AI advisors for the RAG, but just to show you what happens if we don't ground the AI in some sort of logic. So if we just asked it like, what are advisors? So possible things, it could be something AOP related, maybe code quality practices, mentors. So it's trying to be helpful by just offering a little buffet of possible answers, but obviously that's not what we're interested in here. So if we go into our RAG chat here, I used our new popover component here. Thanks for noticing. I'm gonna upload a PDF here that I just extracted from the Spring AI page. It doesn't matter what the source is, but essentially just to make it very obvious that we're working with a document here. So if I upload that and now ask, what are advisors? It should hopefully give us something that's relevant to this. So advisors are components within the Spring AI framework that allow developers to intercept, modify, and enhance interactions with the AI models. All right, so let's say which ones are included by default. So again, here I'm not saying which ones, it doesn't necessarily know that they're related to Spring AI, but hopefully it can. So all right, so here it's saying message, chat memory advisor, prompt memory advisor. All right, so let's take a look at how this actually works. So if we go into RAG chat here, we will, let's see, okay, yeah, here we are. So again, I've given a system prompt, so I'm saying that it's a helpful assistant, and I've given some examples of how I want it to answer, because I want it to act as the expert, not say, because otherwise he would say oh, well, the documentation says this and that, and it kind of sounded wrong. It would be better if it just said how it is. So here I've added a few advisors. So first one is one of the ones that are included here. We can see message chat advisor. So again, the LLMs are completely stateless. So if we don't track the message history back and forth, nobody does. So by just adding this advisor on the request, it will log our outgoing question, and when the answer comes, it will log the incoming answer, and then it'll just keep track of those, and we can use those. The second one I wrote is a standalone question advisor. So this is one that I created myself. There's no such thing in Spring AI yet, although I did talk to Christian, so maybe soon. So this one takes in a chat client. So this one itself will call an AI. And what I have here as my prompt is, given the following conversation, the follow-up questions, rephrase this question into a standalone question. So if we take a look at what actually happens here is, original question, which ones are included by default? It will rewrite that into which advisors are included by default in the Spring AI framework. And that, again, helps us to ask a more relevant question from the AI. The final thing that I added is this re-rank question answer advisor. So similar to the question answer advisor we used with Josh earlier today, it can use a vector database to fetch things. But what I extended it to do is essentially I created a interface for a data source, and the data source that I passed in this case is a vector store data source, which goes to that vector store, but we could add conceivably any number of other sources that we wanted it to go to. And what it then does, let's go here. What this does then as a next step, so it calls all of these data sources that we have, and each one can return however many we've configured them. What's interesting here is that we're using another model which is specifically trained on just looking at how relevant documents are to a given question. And we ask it to re-rank all the documents that we give it. And then I've taken in as a parameter a relevancy threshold. So I can say, like, I'm only interested in things that are more than 0.7 relevant. Of course, this is very much, again, an engineering problem to figure out what that kind of number should be. But this means that instead of me including 10 documents into my context and pay OpenAI many monies, I can pass in 3 documents and pay less monies, which is nice, provided that I'm still getting equally relevant answer. So I think that's something that we're going to see quite a lot. And these are by no means the only techniques that you can use to kind of enhance RAG from the kind of naive version that me and Josh showed earlier today. So it's a very quickly evolving field, so keep searching for new things there. All right, final thing I want to talk to you about is function calling. So the AI is going to be very limited in what it can do in our business context if it doesn't have the ability to call functions in our system. So if it can't fetch things from our database or make a booking for somebody or check somebody's calendar or do something. So we need a way to kind of bridge this gap, make the LLM aware of specific things that we want it to be aware of. So in this case, in the kind of spirit of full stack development, I create a full stack recommendation service that, based on our location, will recommend some foods for that. So if I say that I'm in Frankfurt and click Get Recommendations, it should hopefully suggest some snacks that we should go and have. Rippchen, haven't tried those yet, so we should probably try that. But if we were in Berlin, we would surely not eat these foods. We would have currywurst. So very useful. I see shaking heads. Not approved by Germans. I'm sorry. Anyway, if we look at the actual implementation, which is probably the most interesting thing here, is first of all, we define functions that we want to make available to the AI by, and again, we're using Spring AI here. So we define beans that are type function, and we have, in this case, I created records for both the request and the response. And then I just implement that. So in my case, I'm just using this map that was generated by AI. Obviously, I don't know. These are probably not the right foods to include here, and I should feel bad. But the idea is that this is the bridge where we could inject any Spring service. We could call other services within our application. We could call the database. We're actually in our system when this gets called. So here we can really kind of let the AI do useful things. The only thing, once we've done this, in order to actually use them, is in our chat client definition, we just pass in the functions, in this case, the function names that we want to make available. So again, we had many examples in this particular demo, and each one of them would probably need different functions, but here we can define for each which function should be made available. What happens under the hood is that when we ask a question, Spring AI will add some metadata to that, saying like just essentially a list of functions, what the function names are, which parameters they take in, what are expected values for those parameters, and that way the AI will kind of look at our question and it will see like, there's a function called get snacks that takes in a location, and this person asks for snack recommendations for this location, so it knows, okay, I will call that function, and then once it gets the return value from there, it can use that as part of answering it. So this is something that can really kind of help you build kind of an application that ties into your business. All right, we are getting to the end here. So if you want to poke around this, if you want to kind of add suggestions for patterns you would like to see here that you might not have seen here yet, or if you want to point out why those particular snack foods should not have been on the list, I'll take pull requests. So I'll let all the cameras go down. Right, so then before we wrap up, I just want to kind of tackle this question because I know that I get this question all the time, like, all right, that's all fine and good, but I don't want to send our documents to OpenAI and I don't trust them, so what can I do? Can I still use AI? The Spring AI documentation has a really handy kind of overview list of all the different models they support and which features each one of them supports. And the specific one that is super interesting here is the Ollama model. Looks like that. And this is a program that you can run locally on your computer to run AI models. And this makes it possible for you to do pretty much everything that we did today, but just against your own computer while you're developing, so you're not sending out data anywhere. And that can be super kind of handy during development time. Obviously, the models that are running on my computer aren't going to be as powerful and efficient as something that like OpenAI, but it's still usually, if you're kind of asking specific enough questions and giving good enough context, it will probably still do a pretty good job. And these small models that are running on laptops are becoming better and better. Like a year ago, you couldn't run anything. Today, you can run something that's pretty useful. I was able to get through an entire cross-Atlantic flight and with just local models, and it worked fine. And then kind of when you go to production, you might find a local cloud. I saw one outside my window this morning even, where you can run models that aren't on the public cloud. You could host one yourself. Pretty much any cloud provider these days will have a way for you to spin up your own model that is not going to be somewhere outside your control. So hopefully maybe Control Center will let you do this at some point as well within your Kubernetes cluster. All right, I don't want to keep you from your beers, so I will take all the questions out here in the hallway track. I'll be here all evening. If you have any questions you want to reach out, you can find me in all the places over here. And with that, I want to thank you all for coming, and let's have a fun evening.
Thank you.